Now let us start another project on our exercises of RTI design, but with more computing intensive as opposed to the previous projects that is more process intensive. At the end of this chapter, you will understand how to switch control from one register to another in an RTL system. Switching control from one register to another one is important if our calculation involve changing of source from register to register. This project that is supposedly more the first project that is supposedly more computing intensive is the one that is going to solve or compute greatest common divisor, or in short we call GCD. GCD is the computation of the largest integer that can divide two given integers accurately, which means that is it can divide the two given integers without remainder. This can be found by listing all integers that can divide the two given integers, then get the largest one that can divide both. Let us look at one example. The calculation of GCD for 62 and of 60 and 42. So first we list out the divisors of 60, the numbers that can divide 60 accurately without remainder, aside from 1 and 60 itself. So 2 can divide 60, 3 of course can divide 60, 4 still can divide 60, 5 and 6, but 7, 8 and 9 cannot divide 60. 10, yes, can divide 60. 11 cannot. 12, yes. 60 divided by 12 is 5. 15 can divide 60 to become 4, and so on until 20. 16, 17 and so on until 19 cannot divide 60, 20, and the last one is 30. So this is a list of the number that can divide 60. Next is the list of divisors of 42. 2 can divide 42. 3 can divide 42 to become 14. 4 and 5 cannot, so 4 and 5 do not appear in the list for 42. 6, yes, can divide 42. 7 can divide 42 also, but 7 cannot divide 60. But 7 cannot divide 60 just now. 8, 9, 10 until 13 cannot divide 42. 14, yes. 15, no, until 20. And 21, yes, can divide 42. So we should realize that a few of the numbers in these two lists appear in both of them. For example, 2 appeared in both, 3 appeared in both, and also 6. So the largest among these three, which is 6, is the GCD. So this is GCD by definition. The previous slide just now showed the brute force computation of GCD using the definition directly. In real calculation, we use Euclid algorithm instead. This algorithm says we need to subtract the smaller of the given integer from the larger one repeatedly until they are equal. That equal number or value is GCD. We can convert that wording, we can convert those wording into a more graphical, IT-friendly definition of algorithm, which is a flowchart. We can start from start. We check the two given number. Are they the same? If they are the same, then we can take any one of them, either N1 or N2, to become GCD, and then we finish. But if the two number N1 and N2 are not the same, we check if N1 is larger than N2. If yes, then we subtract N1, then we subtract N2 from N1. Then we go back to the decision of whether or not the two numbers are the same. But in this decision, if this is no, which means we already test that the two numbers are not the same, and N1 is not greater than N2, which means in this case N2 is larger than N1. So we subtract N1 from N2. Then the flow join from the flow join from the other subtraction and goes back to the diamond where we make the decision whether or not the two numbers are equal. So this is the flowchart of Euclid algorithm. Let us redo the calculation for GCD of 60 and 42 again, but now using Euclid algorithm. We start off with 60 and 42, the two given number initially. So 42 is less than 60. We subtract 42 from 60, we get 18. 42 stay in the second iteration. And now 18 is less than 42. We subtract 18 from 42. 42 becomes 24. 18 stay for the next iteration. 18 still less than 24, less than 24. 18 still less than 24. So we still subtract 18 from 24. 24 now becomes 6. 18 stay for the next iteration. Now 6 is less than 18. We subtract 6 from 18. 18 becomes 12. 6 stay. Then next iteration, we still subtract 6 from 12. 12 becomes 6. The 6 in this row stay as 6. And now the two numbers are the same. So this is the GCD. You can Google to learn more about Euclid algorithm in calculating GCD. You will find the Wikipedia entry for this algorithm, and you may find a proof on how this algorithm works. But for this project or exercise, we are not going to go into that. We're not going to go into that deep. We just want to use the algorithm to build an RTL system. So remember just now, we have this flowchart. Again, we need to convert this flowchart into a data flow so that we can construct RTL system from it.